Good morning, students. Today we'll see a topic FLYNN'S taxonomy, which is command and distributed system. So, which is fall under unit 1. So, let's go into the content. FLYNN'S taxonomy. So, taxonomy means nothing but it's a classification, right? So, the scientist, he gave a classification of computer architecture. Okay, it is a specific classification of parallel computer architecture that are based on the number of concurrent instructions, whether it is single or multiple, and data stream, similarly single or multiple, which is available in the architecture. Okay, according to this, based on the number of instruction stream as well as data streams, we can classify into 4 categories, that is SISD, SIMD, MISD, MIMD. SISD means nothing but single instruction stream, single data stream. SIMD means single instruction stream, multiple data streams. Multiple instruction streams, single data stream come under MISD. And MIMD means nothing but multiple instruction streams, multiple data streams. So let's see one by one. So from the name itself, first one is single instruction, single data stream. So we can easily refer that it is a very simple architecture which has a single processor, that is one CPU. It executes exactly one instruction stream at a time. It also fetches or stores one item of data at a time to operate on data which is stored in a single memory unit. Most of the CPU design is based on the von Neumann architecture. So in the early stage we have a von Neumann architecture, right? So in that we follow this SISD, but nowadays we have parallel high-speed processor. Okay, so we are not at all using it. So it is actually a non-pipelined architecture. Why I am saying is, once the instruction is completed successfully, then only the next instruction is fetching and they are doing it. Okay, so from the data put, it will take processing unit, will take the data. Instruction put, it will take the instruction. This instruction will process the data and give the solution. Okay, and only one processing unit is there. So you can refer the diagram so that you can understand. Next, so the next one is multiple instruction stream, multiple instruction and single data stream. Okay, so it is an architecture for parallel computing where many functional units perform different operations uh, by executing different instructions on the same data set. Okay, so here the data set is the same, but we have multiple processors that is working on these various data set, so that literally we are parallelly doing the computation. And this type of architecture is common and it's mainly nowadays used in fault tolerant computers, executing the same instruction redundantly in order to detect and we can detect error as well as we can hide error, that is mask error. Okay, so that's why it is a multiple instruction and single data stream. We have more processing unit. You can refer the diagram so that you can understand. And the next one is single instruction, multiple data stream. It is an architecture where we have a single control unit and more than one processing unit that operate like a von Neumann machine by executing a single instruction stream over processing unit handled through the control unit. So we have a control specialty that will take care of the overall coordinated job. Okay, so this control unit generates a control signals for all the PUs and by which executes the same operation on different data streams. The SIMD architecture is capable of achieving data level parallelism. Okay, so different data can be processed with the same instruction set. That is what happened in this single instruction, multiple data stream. And finally, we are having multiple instruction, multiple data stream. So in this architecture, again, it's a high-level parallel computing. It is here see from the name itself, they have independently we can able to execute different set of instructions and different data items. So that's why multiple processing units are connected with data pool. From the data pool, different set of data are passed to each and every processing unit and with different instructions. So it's like real parallel computing, especially areas like simulation, modeling, even communication switches, manufacturing, computer-aided design. Everywhere we can use this MIMD architecture. So Flint actually give that classification in a better way. We can say that if it is both the single, it's a very traditional one, that is von Neumann single computer, and we have a multi-computer, multi-processor concept means it's come under MIMD. Okay. Thank you for listening.